I'm a developer advocate here at Salesforce. I've been a part of the Salesforce ecosystem for almost 10 years now, and in the course of these 10 years, I've worked with multiple products, including Data Cloud most recently. And I would like to take this opportunity to let all of you know about Data Cloud, and thank you, Amit, for this opportunity. Um, Before we go ahead, of course, forward-looking statements. This product is quite new and it is evolving. So please make all your purchasing decisions based on publicly available information and not based on what I might say today. So that being said, feel free to use the chat window to leave your comments and questions. I will take a look at them and answer them when the time is right. So first and foremost, let's understand what Data Cloud is. And if you've seen the session title that was posted, it said it was formerly Genie. So we launched this at Dreamforce last year, and where we called it Salesforce Genie, and we've given it a more appropriate name now, which is Salesforce Data Cloud. With the name, like all the other clouds, you have Sales Cloud, Service Cloud, pretty much self-explanatory on what services they provide. Data Cloud is going to provide you with data services. But first, let us understand why Data Cloud was launched in the first place. So if you're looking at the slide, you can see that today we have more data than ever, and this data is growing at a very rapid pace. So this data can be all of your transaction data, like for example, you purchased a product, you raised a ticket, and your login credentials. All of this is data that is stored in a system, so that's already there. But these days, with the advent of Internet of Things, our smartwatches and all of this, there's a lot of real-time data that is being generated as well. Whether it is, even if you take a website, all of your website activity is being tracked, so that generates a large amount of data. And according to the prediction that you see on the screen, 100 zettabytes of data is going to be there on the cloud by 2025, which is quite huge. And all of this data has to actually be stored somewhere, and every organization has a bunch of different applications which track all of this data. And again, all the statistics, you can see that there are around 976 applications that each enterprise has, which stores all of this data, but out of which only 1/3 of the data is connected. Now, why do you need all of this data to be connected is for you to get that customer 360. If I, for example, call a customer service desk, they need to know everything about me, and I should not be able to, I should not repeat myself because all the data is already there. It's just that it is not connected. So that is something that every enterprise company right now is trying to achieve, to create like this connected data so that they get like a complete view of the customer. That is what we call the single source of truth, where if you look at a system, you know it is the truth and it is a single source from which you can get all the information. Now, with all of these different applications that are there with every enterprise, connecting all of them is difficult. So you'll need to identify all the different sources. You need to consider the volume. You need to consider how they are integrated to each other. And sometimes this integration is fragile. So if there is a new field added or field removed, integrations might break. So there's a lot of effort that goes into how you connect all of these systems together. Now, Salesforce, it does provide a lot of tools. I mean, even before Data Cloud, you had this customer 360 vision that you could achieve with Salesforce. We gave you all of the tools that are needed to integrate. Or if you wanted to virtualize data, you had things like Salesforce Connect if you didn't want to copy the data into Salesforce. And of course, you have MuleSoft. So all the different tools and technologies were in place, but it was left to you to decide how you wanted to integrate all of these systems together. So each and every organization had their own way of doing it. And it's kind of like reinventing the wheel because everyone is looking to do the same thing. So which is why we launched the Salesforce Data Cloud. And the whole purpose of Data Cloud is for you to create a single source of truth of your customer using both your transactional data and real-time data, both the things that we discussed. in the first slide. So Data Cloud can combine both of these together to create a single source of truth. And it doesn't just stop there. All of the data inside Data Cloud is actionable as well. Now, over the course of this presentation, you will understand what actionable means. But that, in theory, is the definition of Salesforce Data Cloud. Now, how Data Cloud really works. The first and foremost step is for you to connect all of the data sources together, which is what is the problem area that we discussed in the previous slides. Now, Data Cloud is not something that is apt for all of your use cases. Now, if you have only one system that you're working with and you want to integrate data from that one system and get it into your Salesforce org, you shouldn't technically go towards the Data Cloud route. There are certain use cases where Data Cloud is really going to shine, and some cases where it is overkill. So that is left to you as the implementation partners or advisors to the customers, or if customers are tuning in, you will have to decide whether Data Cloud is right for you or not, and our account executives will help you decide that. The whole concept is that you'll need to have multiple data sources from which data is going to come in that can be processed inside Data Cloud. Now, these data sources can be your Salesforce CRM orgs. It can be your third-party cloud storage. If you have data on, let's say, Amazon AWS, you can get that data as well. If you have data on websites or mobile apps, you can get that into Salesforce or Data Cloud. And if none of these connectors are sufficient for you and you have like these legacy backend systems that are not capable of directly being integrated with Salesforce, you could obviously go via the MuleSoft route. So there's a MuleSoft service in between that talks to both your backend systems and pushes the data into Data Cloud. So that's pretty much the first and foremost step, getting all of your data sources together and getting all of the data into Data Cloud. Now, this data coming into Data Cloud, like I said, the data is going to be both transactional and real-time data. So the data coming in can be ingested both in batch, that is a bunch of records come into the system at once, or it can be a streaming ingestion as well. So for example, real-time data, like let's say your smartwatch is sending out your activity data. Let's say you're taking a run now, and that run data is being captured by Data Cloud. That's going to be real-time, and that's what we call a streaming ingestion. So both of these are possible. Depending on your use case, you can choose which one that you want. Now, all of this data coming into the system is going to be in different formats. For example, let's say you're loading the customer data from all these different data sources. Now, within Salesforce, you have the data in leads and contacts, if you talk about people. And the same customer might be present in your Marketing Cloud instance as a subscriber. And if you have Commerce Cloud, they are saved in Commerce Cloud as a profile. So the same customer saved in a bunch of different systems in a bunch of different formats. Now, what you'll do in the harmonize step is map all of those different formats into a common format, which we call the customer 360 data model. There are other names that you'll hear on the internet, like canonical data model or cloud information model. All of those mean the same. Basically, it's a bunch of objects that we give you along with Data Cloud, to which you can map all of these different objects, so that after the step of harmonize, you are working on a consistent data model. Irrespective of where the data is coming from, what format the data is in, you can all map that to one common data format, because it's going to be easier for you to build the applications on this common data format going forward. So that's the harmonize step, where you'll get all this bunch of different data, map them to a common data model. Next is the most important step, which is unify. Now, even though you map all of this data to a common data model, let's say you've mapped the subscriber, you've mapped the profile, and you've mapped the lead. Now, there are three different rows in your data model corresponding to the same customer. Now, the unify step is basically going to combine all of these three rows and generate one unified record, which is going to be the unified individual, is what we're going to call it. So that is a unification process that's going to happen, and that is how you're going to define a single source of truth. Now, this unification process is not going to just store your records in a new table, it's going to have backlinks to all the relevant tables from which the data has been aggregated. So if you look at a unified profile, you can backtrack and go and see from where this profile has come in, how it has been unified. All of that lineage is going to be maintained within the unification process. Now, once you have this unified profiles, once you have the single source of truth, then you can run analysis and predictions on it. For example, if you want to push this data into Tableau to generate some nice reports and dashboards, you can do that. If you want to train your AI models on this data, you can do that. And if you want to send this data to third-party systems like Google AdSense for customers to see ads based on this data, you can do that. But that's not all. This data can be fed back into the CRM and action can be taken on it. And how do you do that is with flows. So whenever something happens in Data Cloud, you can trigger a flow. And once you are able to trigger a flow, you know the possibilities that a flow can do. So that way, any data that is in Data Cloud can be actioned upon within Salesforce. Of course, it can be actioned upon all of these different systems as well. But overall, this is how Data Cloud is going to work to really generate that single source of truth and give you the ability to take action on data. Now, I spoke about use cases for Data Cloud. Not all the requirements that you have can be thought of. The Data Cloud cannot be a solution for all of your requirements. Some can be met without Data Cloud as well, so you'll have to pick and choose. So here are a few use cases. The whole concept is you need to have multiple data sources. If you do not have multiple data sources, think twice about why do you want Data Cloud. Now, across all of these industries, I gave you different examples before I told about a smartwatch, which comes under healthcare and life sciences. So you can create like a health score out of all of the data that is coming in and assign like a risk category for your patients and identify how do you want to target them. For financial services, again, there are many things you can do. I mean, the slide is there, you can look at it. Things like if you want to calculate the lifetime value of a customer. For example, all of these banks are going to award statuses or benefits based on your lifetime value or how much money you have with them. So those are the kinds of things that you can do. And you can take action on real-time data as well. For example, your credit card is lost and somebody is making a lot of fraudulent transactions on your credit card. In real time, you can have Data Cloud monitor all these real-time transactions and have some metrics on top of them to decide if it is fraudulent, add artificial intelligence, and appropriately take an action by blocking the card or doing something. Even before the customer calls you, based on the transactions that are happening, you'll be able to take action on the data. So all of these are different use cases that you can look at and decide if Data Cloud is the right product for your use case. Now, what makes Data Cloud so special, why are we talking about it a lot, is it's not just a tool that sits outside your platform. It's not like you're using a totally different tool altogether and trying to integrate it with Salesforce. You don't have a learning curve on there. Data Cloud is natively integrated into your Customer 360 platform. So if you look at the layers that are there in Salesforce, Data Cloud sits at the very bottom, which says it is very fundamental to all of the different applications that are there that are built on top. Now, this is a very high-level slide. To really understand how Data Cloud has been implemented and why are we saying it is deeply integrated into the Salesforce platform, you'll be able to understand it using this slide. Now, the best way to describe the architecture of Salesforce is that it is a layered architecture. And each layer can take advantage of all the services that are below that layer. So for example, if you're building a Lightning application, irrespective of what application you build, whether it is a standard application or custom app, it's going to leverage your Lightning UI, it's going to leverage Einstein, it's going to respect your security and access control, and it's going to store your data in a database. So That way, the layer on the top is leveraging everything that is happening below it. Now, I spoke about two kinds of data. One is transactional data. And what I mean by transactional data is that data that is updated frequently. If you take your account record, you click on edit, you change some details, you click on save. It's updated frequently. And that's what we call transactional data. And Salesforce has always optimized its databases to handle transactional data really well in terms of CRUD operations, in terms of ensuring your data is not lost. We have optimized the transactional database to work seamlessly, and it's been working seamlessly for the past 20 years. Now we have a whole lot of real-time data that is coming in. And this real-time data typically is not transactional in nature because that data is almost always immutable. For example, if you take a weather reading, the weather reading today, once you've taken the weather reading, it doesn't change. It stays there forever. Similarly, with your health data, whether you've taken a blood pressure reading or your heartbeat, that data is constant. It doesn't change, and that data is huge in volume. And that kind of data is not really going to be stored in a transaction database. It's not the right fit. There are lakehouses and lakehouse architectures that well cater to the scale of the data that is going to be coming in from real-time data, which is why Data Cloud offers a lakehouse architecture. And this lakehouse, if you notice the diagram, it sits right beside the transactional database at the bottommost layer of Salesforce. So the layer on top of these databases is your unified metadata dictionary. As you know, Salesforce is metadata driven, and this is the layer that controls how your production org is going to look at runtime, whether it in terms of your multi-tenant architecture. If you're logging into Salesforce, you only look at your data. So all of that, your metadata, all of that is going to be handled by the metadata dictionary layer. And because the transactional database and lakehouse database or the lakehouse are at the bottommost layer, every layer on the top can have access to lakehouse data using the same UI and using the same concepts that you know and work with regularly with transactional data. For example, security and access control. You can define security on transactional data. Very similar, you can define security on lakehouse data. But there is a catch. Because lakehouse data is different, it operates differently, we might not enable all the features on lakehouse data. For example, if you want to define security on your transactional databases, you can either use attribute-based security, or you can do role-based security, that is your user-based security and stuff. But on lakehouse data, we only support attribute-based security and not ownership-based security. So there are a few limitations that we deliberately put in place because certain things are not really meant for the scale of data that is there in lakehouse. As and when you're implementing features or applications on top of Data Cloud, please check the documentation to really figure out what the limitations are and what is supported with your lakehouse data, so that you don't run into issues later. Now, what it means practically. So until now, whatever I spoke is at a very high level. I told you what Data Cloud is about, what it supports, what it doesn't. But as an admin or a developer tuning into this session, what does it really mean for you? What does this whole architecture and having things at the bottommost layer, what does it mean? For no-code and low-code developers, that is admins, all of your setup and configuration is available natively through the Salesforce setup UI. So whether you want to set up your data streams, you want to create data models, you want to do all of the different stuff that I'm going to show you, you can do that using the interfaces that are familiar to you. You can use flows in order to trigger actions. You can use flows to make Data Cloud do something because it's all built into the same platform. And ISV partners tuning in, you can also create packages and deploy these packages onto your customers' orgs. So all of that is possible because of this native integration. Now, if you're a pro-code developer, you're actively writing Apex and Lightning Web Components, you can query Lakehouse data using SOCL. You have Connect API classes with which you can access data. And there are different APIs and SDKs that we provide using which you can integrate with Data Cloud. So all of this is possible, but like I said, with a few limitations. Now, what are those limitations? One limitation that I can talk about is, even though you can use SOCL on Lakehouse data, you can't really use any of the aggregate functions or joins or inner queries. All of that will not be possible using SOCL on Lakehouse data. You can do all of that using SQL, but using the standard Salesforce object query language, you won't be able to do all of the other stuff, other fancy stuff. Your query only has to be very simple. And when it comes to triggers, you cannot write your before and after triggers on Lakehouse data, because at that scale, it doesn't make sense for you to write triggers on that data, which is why we have deliberately chosen not to enable triggers on Lakehouse data. But that said, asynchronous Apex triggers are possible because any change in data in the Lakehouse can trigger a platform event, and you will be able to listen to the platform event and write asynchronous Apex triggers or flows. So those are some of the limitations that we have. Now, that was enough slides. I'm sure all of you want to see Data Cloud in action. So this is going to be a demo flow. All the features that I have spoken about is something that I'm going to show you today, starting from data ingestion, how you're going to get data from all the different places, to how you map them to a common data model, how you create a unified profile, and how you create calculated insights on top of it. So let's quickly jump to the demo. And hopefully this has not timed out. Okay. All right. So here we are in the Data Cloud instance. And as you can see, it is all very familiar. It is all Salesforce. You have these tabs, you have apps, you have Lightning components. Everything kind of pretty much looks the same. So just like you won't see any difference between Sales Cloud, Service Cloud, you won't see any difference between Data Cloud as well, even though architecturally it is a little bit different. Now, in order to start off, the very first thing that you do is you want to get all of the data into Salesforce or Data Cloud. What you do is you create a data stream. And there is a list of all the data streams that are already there. And scale is definitely not an issue. We are capable of processing millions and billions of records. And some customers are already doing that live on production. So definitely don't worry about scalability. So to create a new data stream, you click on new, and it'll take some time, but eventually there should be a pop-up that is going to come in. And there we go. And you can see all the different data sources from which you can get the data, whether it is Marketing Cloud, whether it is Salesforce CRM, whether it is your website, or any of all systems using which you can get the data. All these other systems are routed through MuleSoft, but there are native connectors that are available with Salesforce as well. Now, how do you set up these connectors? So for the connectors to show up here, you need to first configure them. And that happens in Data Cloud setup. So again, from the gear icon, just like you have setup, Service Cloud setup, you're going to have Customer Data Cloud setup, which is going to get you to this page. And here is where you can configure all the different connectors. Now, there are permissions involved. So Data Cloud comes with a bunch of permission sets. All of the users need not have access to this setup. All the users need not have ability to create data streams. All the users need not have ability to create segments. So there are certain functions that each job role has, and we have created different permission sets based on these job roles. And here is a table that summarizes all of this. And this same table is actually, this table is a screenshot from the documentation. So this is available in the documentation. So you can go look at it. Depending on what operation you want to do, what operation a user is allowed to do, you will assign the necessary permission set to them. And depending on their permissions, they will be able to do certain things and not do certain things on Data Cloud. Now, since I'm an admin, I can do everything. So first and foremost, let's see how you can set up a Salesforce CRM connector. So click on Salesforce CRM, and you can see a bunch of different orgs to which we are already connected to. Now, all you need to do is click on New and choose Connect to another org. And the moment you click on Connect, you will be taken to the login page of Salesforce. And to whichever org that you want to connect to, just put in the username word of that org, and the connection will automatically be established with that org. And that's it. That's the most simplest thing that you can do. Connecting Salesforce is by far the easiest one. Um, so this step will only connect two orgs together. You need to create a data stream for data to flow in. So I'm going to choose a Salesforce CRM connector and click next. I'm going to choose which org. And by the way, the org that you connect can be the same org as well. So to get the data from the same org, you need to connect the same org. It should be available as a connection. So once you choose the org, you can go ahead and click on all the objects, and it's going to show you all the list of objects that are available in the org. Choose the object that you want to get the data from and click on next. And this object is going to flow in, and you're going to select what all fields have to come in. And most importantly, you're going to choose the category of this object. Now within Data Cloud, you can create objects of three categories. One is the profile, one is engagement, and one is the other, as you can see on screen. Now, what is the primary difference? Why do you need to assign this category? Is because certain capabilities are going to be enabled only on certain types of objects. For example, if whatever you're getting is an engagement object, so engagement object is kind of your real-time data. So the data is going to have a timestamp and stuff like that. So there are certain things like time-bound queries. So let's say you want to get all of the interactions that have happened in the last 10 minutes. So it's a time-bound query. And these time-bound queries can only be run on engagement objects and not on profile objects. So there are certain nuances that certain types of objects allow you to do and certain type of objects do not. So depending on your requirement, choose the category appropriately. And then if you click next, this data stream is going to be created. Now, I've done that. In order to get all of these different objects, I've gotten accounts, I've gotten cases, I've gotten contacts, products, and all of these different objects from my Salesforce org. Now, the reason I'm showing you all of this separately is because for every object that you want to get into Data Cloud, you need to create a data stream for that. If you want to get a bunch of objects together, you could have actually chosen data bundle as well, where if you choose CRM and go to next, you have what we call data bundles, where a group of related objects can be brought in together instead of you having to select each object individually and create a stream. So you can choose any of these, and it shows you that 3 objects are going to automatically come in. So it saves you a bunch of clicks. So that's how you get data. And the important part is once the data comes into the system, there are different frequencies in which the data is going to be refreshed. And that is mentioned on here. So for example, on your Salesforce org, once you get a data stream, the data is going to be refreshed every hour. And the first load that is going to be there, it is going to be a bulk load of all of the data that is there. After that, there are going to be subsequent upserts that are going to happen on the data in order to optimize performance. And in the background, every week, we again do a full import. So you're not really in control of how we do the imports and what frequency. Even though it is documented, you can't just randomly come and say, okay, now I want to import all of the data. It is automatically done by the system to not affect the performance of Data Cloud. So data is only refreshed hourly for Salesforce CRM orgs, and a bulk refresh is done every other week. So that's how it is. And depending on your connector, the data refresh frequency varies. For example, if you see for this particular connector, which is Marketing Cloud, there is a daily refresh that is happening. So all of that is documented. Again, if you look at the data stream schedule, you can see depending on the objects itself, whether it is daily, whether it is hourly, whether it is every 15 minutes, everything, the refresh frequency depends on your connector type. Now, we've seen the Salesforce CRM connector, but there are a bunch of different other connectors. For example, website connector. Now, data coming in from your CRM is mostly transactional. Now, the real-time data, the actual real-time data is going to come in from all these different data sources. Now, the use case that we have here is, I'm sure most of you should be familiar with the e-bike sample app, which is what we use to demo Lightning Web Components most of the time, apart from recipes. So e-bikes sample app, which an electric bike reseller uses in order to sell their bikes. So assume they have a public facing website like this, where all the different products are shown. And if they click on a particular product, they can look at the detail page of that product. Now, what I want to do is I want to capture the user engagement on this website. And by the way, this website is hosted on Experience Cloud, just so that you know we are all in the Salesforce ecosystem itself. Now, what I want to do is I want to capture the clicks. I want to track which product is being mostly purchased by customers. That can be done using the reports on orders. But what if I want to track the product that is being mostly viewed by the customers? So are they clicking on this product? How many clicks is each of these bike receiving on the website? If I want to track all of that, I can do that using Data Cloud. And that data is going to flow into Data Cloud as well. So in order to do that, we are going to use what we call the web and mobile SDK. So to do that, you are going to click on websites and mobile apps. And here already have set up a connector. Or you can just set up a new connector, let's say demo, and choose the connector type, whether it is a mobile app or a website, and you click on save. Now, what it's going to do is, if you look at the very bottom, it's going to show how you can integrate your website with this particular SDK. All you need to do is add the script to your web page, and there are certain functions that the script exposes. You just call that function with whatever data that you want to send to Data Cloud. Now, this is very similar to how analytics works. For example, if you have used Google Analytics before, you also do the same thing. There is a script, you load that script, and you call methods from that script in order to send tracking data. So that's something that you'll have to do, and that's something that I've already done. So within Experience Cloud, I've put this JavaScript file in the header, and within my Lightning Web Components. So here is a product tile list web component that is behind the tiles that you have seen on the UI. I am actually making a call. So if you see handle product selected is the method that is called whenever you click on a tile. And within this, I'm actually calling a function from the JavaScript resource that I've loaded. So it says Salesforce interactions.send event, and I say what is that event. So here it is, the event name is view catalog object. Along with that, I'm sending a JSON of some other details, like what is the ID of the product that is viewed, what is the category, what is the material, and so on. So that I can work with this data inside Data Cloud. Now, the most important thing that you'll see here is the consent. As you know, we take trust and consents very seriously in Salesforce. And if a user is clicking on a tile and you're tracking it, you need consent of a user to track whatever they're doing. And you need to capture that and send that information as a consent status. And unless you send the status as opt-in, this tracking data will not be sent to Salesforce. If the status is opt-out, even though this method is being called, there is no data that is being pushed into Data Cloud. So we take care of that internally. Just ensure you are not hard coding this like I've done here. It's a demo, so I've hard coded it. Ideally, you need to have that consent module, have a bunch of checkboxes, and only if they check that box, you're going to send the opt-in status. So this is the code on how you can very simply integrate or send tracking information from your website into Data Cloud. In order to see if it actually works, So here we are in the network tab. If I click on, let's say, Dynamo X2, you can see that there is a request that has gone out to the web/events endpoint that is given to me by the web and mobile SDK. And in the payload, it's all encoded, but we have sent the product information back. Now that was step one, where you've configured a connector and you have sent the data. But the data you send is in a JSON format. So if you see here, it's a bunch of random JSON, and you can have any number of attributes that you want. But how are you going to let Data Cloud know that these are the attributes that are being sent? So what you're going to do is upload a schema into this connector, which basically talks about all of the different data formats that you're going to send in. So once you do this, Data Cloud knows that, okay, you're sending a cart item or some information, and it is going to have so and so number of fields. So that's something that you'll have to do to set up this connector. And like I said, once the connector is set up, you can click on website, choose whatever is the website from which you're trying to get the data, choose the event that is being sent, and click next. And that is how the data stream is going to be established. And that's what we have done for e-bike site behavioral events. So this is the data stream that is coming in from the website. Now, how do you test if this integration is working correctly? First and foremost, you can see it is active and so records have been processed. But how do you actually verify if all of the data is coming in or not? So there is a tab called Data Explorer within Data Cloud that lets you look at the objects that are coming in. So here it is going to be e-bike site behavioral events. I select that, and it's going to show me a list of records that it has processed. I can choose to edit the number of columns here. So let's say I don't need the page view, but I would need the date and time on when the event was captured. So I can choose that, and it's going to this data. I can sort, and hopefully here you can see that there is an event that has just been received before the demo. I've clicked on it, so I got the data. Now this data coming in is not going to be actually real time. It's going to be near real time. That means it is going to take about 2 or 3 minutes for the data to actually reflect into my table. So because it is a web and mobile SDK, it is 2 minutes. If it was some other thing, it could be 15 minutes. So like I said, please take a look at this documentation to figure out when the data is going to be available to you. Now that was the second type of data stream that I've shown you. The third one is the ingestion API. So Salesforce is API first, and similarly, Data Cloud also obviously is going to be API first. And we have a bunch of different APIs that Data Cloud has. And there is a handy little Postman collection in the Salesforce developers workspace that you can take a look at. Now in here, you'll see we have both direct APIs and connect APIs. In here, you have, let's say, the ingestion API. Within that, the ingestion API supports both streaming and bulk. So if you want to load a bunch of data into the system at once using the API, you can do the bulk. And if you want to send in streaming data, that is, data is going to come in one after the other, live data, you can use a streaming endpoint as well. Now here is a sample request of sending in streaming data. So the use case that I'm trying to show here is that assume the customer has purchased the bike after exploring it on your website. They are riding the bike, and the bike is continuously sending data to Data Cloud in terms of what is its battery percentage, how much mileage it is giving, what is the efficiency. So all of this live telemetry is being sent to Data Cloud by the bike. So assume there is a module on the bike that is calling this API. But for the purpose of this demo, we are going to do it using Postman. So here you can see there is a sample request, and there is an endpoint to which we are sending data. and I click on send. And once I click on send, of course, there is this authentication process in the background, all of which I can show it to you in more detail in a different session. Um, Ideally, it shouldn't take this much time. What it should return is accepted colon true as a response, which means this data is accepted by the system. Again, like I said, it's going to be processed and it's going to reflect in your tables in like about 15 minutes, because that is the delay that ingestion API has. So while this is going on, um, we will see how you can set up ingestion API. So again, go to the setup, click on ingestion API, and configure the different tables that you want to ingest. So very similar to your web and mobile SDK, you're going to have to define the schema of the data that you're sending in so that it can be mapped. So that's pretty much it. It's the same steps. Click on new, give it a name, upload a schema, which corresponds to whatever is the structure that you're planning to send in. And that schema is going to be stored within Data Cloud. And of course, you can take a look at all of this using our Data Explorer as well. So here are all of the details. This is the most recent entry that I've done just some time ago. Now that was the very first part. As you can see, the setup is going to take some time. You'll have to carefully plan out your setup. Now, once you have all of these data streams, what do you do next? The second step, as you know, is to map all of these to your canonical data model. So for that, what I can do is I can click on a data stream, and it's going to show you a bunch of different details along with a tile for you to start mapping the data. Click on data mapping. It is going to show you this drag and drop UI, where you can map the data from your source object, which is the data that you have ingested into the system, into the target data model object. So here you can select any of the objects from within our cloud information model or the canonical data model. So search for it. Let's say you want to map it to the individual object. Ideally, it's come here. So you can just click on plus and click on done. So the object is going to be shown. The fields are going to be shown. To map, just click on this button here. Let's say primary key, and map it to the external record ID. So this is how simply you can map this data. Now, this mapping happens between two objects. One, what we call the data lake objects, and the other one we call the data model objects. So whenever you've created a data stream, all of the data is going to come into the system and it's going to be dumped as is into a data lake object. And data model objects are the ones in your canonical data model. So you map the fields from the data lake objects into your data model objects. That's all the concept there is. Now, when it comes to your data model objects, there is an extensive data model that is there. And like I mentioned before, within this, you're going to have your profile objects, you're going to have engagement objects, and you're going to have other types of objects. So other types as in, let's say, payment details, payment history. That doesn't classify into engagement or profile, so you can tag it as other. Apart from this classification, what we also have are subject areas. So the data model is quite huge. So we've grouped entities into what we call subject areas. For example, if you're looking at consent, consent is going to have a bunch of different objects. So all of that can be grouped under your consent subject area. And you have a different subject area for engagement. For example, there are different kinds of engagement, whether you have browsed a product, whether you have added an item to a shopping cart, whether you have placed an order, all of these are different engagement types. And we have data model objects available for each of these kinds, which are classified under the engagement subject area. If you want to dive deep into the engagement data model, there is again this huge relationship diagram that is available. So as a developer, as an admin, as an architect, you'll have to make yourself familiar with all of the different standard objects that we are offering within the canonical data model. And if none of these meet your requirements, only then you're going to create custom objects to store all of your lakehouse data. Now, where can you find all of these different data models is on the Salesforce Architects website. So as you can see, there is a customer 360 data model tag under which you have all of these 5 different data model entities, which you can then refer to. So you map this, you create all of this mapping, and eventually what you're going to end up is with something like this, where a bunch of different fields are mapped to a bunch of different objects. And if you click on the data model tab, you're going to actually see a representation of your data model in a very pictorial format. So at the center is going to be your individual object, which is the person for whom you're tracking all of this data. And as you can see, this individual is related to a bunch of different objects. So here we have product browse engagement, which is the data that is coming in from my website. And I have my purchased bikes, which is coming in from CRM. And if I scroll a little bit, you can see each of these purchased bikes is in turn related to the live battery status. That is, this table is coming in from the ingestion API. So you can create a relationship between all of these objects so that you can write queries in order to fetch related data as well. Now, the way you can define relationships is you go to a data model, you click on a particular data model object, and you click on the relationships tab. And here you can see how this object is related to other objects. So here it is a product object. So it's related to both the purchased bikes and the product browse engagement. And the relationship is many to one. That means one product can have many product browse engagements, and one product can be purchased multiple times. They will have different unique identifiers, but the product is one, the asset is many, right? So that's the kind of relationship that we've tried to establish. So this wraps up the setup part of it. So you have the stream, you've gotten the data, you've mapped all of it to a common data model. Now the next one that you do is create identity resolutions in order to unify all of the data together. Now, to create an identity resolution, you go to Identity Resolutions tab, you click on the rule set, or you create a new rule set that you want, and basically define a bunch of what we call the matching criteria on how you should identify different rows which are the same. So either they have a name that is similar, which is a fuzzy match, or the email, which is a normalized match, or if you want to match based on the phone number, which has to be exact or normalized, that is up to you. So you can define a bunch of different matching rules based on how you want to create the data. You can create a custom rule of your own and say on this particular individual for this field, mailing name, it has to be an exact match. So that way you can create your own custom rule apart from the standard rules that we already ship, which is fuzzy name normalized email, fuzzy name normalized phone, and so on and so forth. Now, you're trying to unify this data together. You've identified 3 records which have the same phone number, and you have combined them into one individual. But it turns out that there are a bunch of different other fields. So let's say like the address, which is different on all the 3 records. So how do you choose which is the winning address? So that is what we define in reconciliation rules. And what reconciliation rule specifies is what is the criteria on which the winning record is identified. So either it is most frequent. So let's say out of the 3 records, the same address appears twice. Should that win? Or based on the source priority. Maybe your CRM has the most up-to-date information all the time. So consider the CRM data sources values in priority over the data coming in from, let's say, Marketing Cloud. And there is a third type, which is called last updated, which means whatever is the data that is most up-to-date, which is the last updated, that is going to win. So those are the reconciliation rules that you can identify. And once you do that, the processing happens in the background. And once processed, it's going to show you how many unified profiles have been created. So for me, because I have sample data in my instance, not a lot of duplicates. So only 2% have been consolidated. Everything else is a unique profile. So that's what I was able to do by creating an identity resolution and creating a single source of truth. Now, after this point, you're going to take action on the data. To to create, there are multiple ways in which you can create actions. So the very first and foremost thing that I want to show you is calculated insights. Now, what calculated insights are is it's a multi-dimensional metric that you can pull from all of the data within Data Cloud. So if you remember the use cases that I was talking about earlier, maybe you want to identify the lifetime value of a customer. If a customer has been banking with you for quite some time, whether they have like 10 years of history, the amount is greater than 1 crore, something like that. You have a bunch of different criteria that you want to pull, and then create a metric out of it and define, based on this criteria, these are the people who are going to come into this category, or in the gold category, how many members do I have? So these are all metrics that you can pull from your existing data, and that is what you do using calculated insights. Now for our use case, because we were talking about e-bikes, now I want to pull an insight on what are the most purchased products. So for that, what I've done is I've written a SQL query. So this is not SOQL, this is plain old SQL. And the reason we've written SQL is because we are dealing with lakehouse objects. It supports SQL. So what I can do is I can write a SQL query. I can use inner joins. I can use group bys. All of that fancy stuff that you can do with SQL can be done in order to pull a calculated insight. Now, once you've created a calculated insight, again, how do you verify if it is working correctly? Go back to your Data Explorer, click on Calculated Insights, and select the calculated insight that you want to see the results for. And you can see it's summarized all of my data based on the query that I've written, and it is showing that these are the number of orders that have been placed for each of these products, based on which I know which is the most purchased product that I have. Now, this is one kind of calculated insight which happens on data that is already there in the system. Now, what if I want to have a different kind of insight which is live, which is based on real-time data? For example, I have a calculated insight here that says, I want to see the product that has been most viewed in the past 30 minutes. So this insight is going to be calculated based on the live data that is coming in. And these kinds of insights are called as streaming insights. So calculated insights are the one that are calculated in bulk. Streaming insights are the one that is calculated on real-time data. So for that, again, if you click through it, you can see that, again, it's a very simple SQL query. But like I mentioned, because this is an engagement type of an object, you can create time-bound queries. So here you specify a window by saying this engagement time should be a 30-minute window. So within the past 30-minute window, what are all the engagements that I've gotten? Please aggregate them and show me the result is what this calculated insight is saying. And back in your Data Explorer, you can look at that data as well. So here is the data based on the timestamp. It's identified from 9 to 9:30, this product has been viewed the most. From 4:30 to 5, this product has been viewed the most, and so on and so forth. Now, if you're somebody who's not very familiar with SQL and you still want to create a calculated insight, what you can do is you can open the builder. So for example, if you go to the most purchased products, you can actually create this insight or the SQL query using a drag and drop builder, which is going to look very similar to your flows. So here it is. Here I have a table. I have a bunch of different fields. I'm getting another table. I'm joining both these tables together using either inner join, right join, left join. A bunch of different options are given to you. And finally, you can aggregate all of these details. So all of this is pretty much drag and drop, and you can use that to create a calculated insight. Now, once you've created this calculated insight, you can also surface them within your Lightning Web Components. For example, here is a Lightning Web Component on my homepage that shows the 3 most purchased products, which I'm deriving from the calculated insight. Now, how do I do this? Is using Apex. So within Apex, if you can see, there are a bunch of different methods. So first, I'm going to talk about this method where it is a simple SQL query that I have written in order to get a particular individual. Now, this is just an example to show you that you can run a SQL query. Sorry, did I say a SQL? This is actually a SQL query. You're using database.query and you're writing a SQL query on the individual object. That is your data model object in order to get the data. And as I mentioned in the limitations, it cannot have like subqueries, it cannot have group by, aggregate, and all of that. It's going to be a simple query. But coming to our example, which is to get the most purchased products, I'm using the connect API methods. And within connect API, I have a method called as query calculated insights. So within that, I specify the API name of the calculated insight I've created. Optionally, let's say I want to sort the table by count in the descending order, and I want to limit it to 3. So there are a bunch of different parameters that this method accepts. So I send in all of that, I get the data back, and I'm able to show it. There is a bunch of other processing logic, but this is all you need to know, that calculated insights can be used within your Apex class as well. Now, very similarly, there is another use case where I have a purchased bike record. And on the purchased bike record, I want to see all of the metrics that are coming in, that is the battery readings that are being sent from the ingestion API. Now, to show this data, I'm actually directly querying the table. Now, the way I'm doing it is again using the connect API methods. I could also use SOQL, but the reason I'm showing you this example is because using the connect API, you can write a SQL statement. So you write a SQL statement based on 2 different tables, you combine them, you use inner joins, you use limits and so whatnot. And this SQL statement can be executed right from within your Apex as well. So what I'm trying to show here is you can use SOQL, you can use SQL, you can use calculated insights. So all of this is possible. So all the data that you created in the UI is accessible within your Apex class as well. Now, coming to the end of the demo, until now what you've seen is data that is being pulled. So I'm creating a calculated insight, I'm pulling the data into Apex, I'm invoking it into Lightning Web Components, I'm writing a query. So I'm trying to fetch data. But what if I want data to be pushed to me? So what if I want to be notified when something happens? So that is when you create what we call data actions. And data actions are nothing but platform events that are going to be triggered based on certain criteria. So let's say you want to create a new data action. The target is going to be a Salesforce platform event. And when you click next, you can choose what should trigger this platform event, whether it is a streaming engagement object or whether it is a streaming insight. So the use case for this is going to be, let's say you're getting a bunch of different readings from the bike battery, and suddenly you notice a fluctuation. And this fluctuation can be derived based on the calculated insight. And the moment a fluctuation is noticed, you can actually trigger a platform event. And that platform event can be then captured within a flow or an asynchronous Apex trigger, and then fire off a different workflow. So whether you want to send them an email or whether you want to create a task to follow up with that particular customer, whether you want to automatically create a case, that's totally up to you. So choose platform event, choose the streaming insight or engagement object from which you want to send platform events, and then click next, choose certain filter criteria if you want, and then create a data action. Now, like I mentioned, this data action, this platform event is going to be captured via a flow. And the name of the platform event is data object data change event. It is not going to be specific to each and every data action that you create. So each data action is not going to trigger a unique platform event. All the data actions are going to trigger the same kind of platform event, which is the data object data change event. Now, within your flow, you will have to filter based on certain criteria to only look at platform events that are triggered from a given calculated insight. So typically, the platform event that is sent is going to have the payload in a JSON format. And within this JSON, it is going to mention what kind of object has triggered this platform event. So you'll have to filter based on this. If it was Apex, you could obviously parse this JSON, get this data, and see, okay, this is the kind of object that has triggered this event, so I need to process it. If not, I ignore that platform event. But in terms of flow, you don't have native ability to parse a JSON, which is why you need to have an Apex method in between that parses this JSON and gives the output of the kind of platform event it is. And then you write a decision element to actually check if the record action identifier is the calculated insight that you want or not. So that's pretty much at a very high level on how data cloud works. And of course, within Flow, it's not just listening to all of your platform events. You can trigger certain things as well. For example, these are the actions that are available to you within a flow. So let's say if you want to publish a calculated insight at a given point of time, there is a flow action. You can just write that, drag and drop that into the flow, and you can only call it 3 times in 24 hours. So there are certain limitations that are there. Coming to packageability, like I mentioned, ISV partners can create packages. And the reason you create packages is, for example, you want to create an out of the box, or you want to create a connector, and then you want to create your own calculated insights, and then you have your own flows that you have built on top of the canonical model. So you can package all of that and create what we get that can be installed by everyone else. So once you install a data kit, if you have data streams within that, they're going to come in. All the data mappings, all your calculated insights, all your flows, all of that is going to flow in to your org in which you have installed the package. And for ISV partners only, you can actually create scratch orgs with customer data platform enabled, or data cloud, as it is now called. This is only for ISV partners. So if you're not an ISV partner and you try to create a scratch org by adding this feature, the org is going to get created, but it is not going to have data cloud enabled. So it's only for ISV partners. So I think we've reached towards the end. I've been talking a lot for the past 1 hour. I'm sorry if some of this has gone over your head, but it's a lot. It's an overview that we are trying to cover. So I'm hoping this has been good use of your time and you've gained at least a little bit insight into what data cloud is, how it works, and how complex or easy it is to set it up. If you want to learn more, learn about best practices, and stay up to date with all the launches that are happening, please join the new data cloud community group. The link is there on the slide. Once the slide deck is shared with you, you can just click on that, or it's a short link, you can type on it as well. Not just that, I've covered everything at a very high level today within like an hour. What we are coming up with is a new data cloud video series, which is going to be a bunch of short videos explaining each of these topics in greater detail, right from the click path, how you configure it, how it's going to work, how you debug it. So all of that is going to be covered in a new data cloud video series that's going to be launched soon on our Salesforce developers YouTube channel. So hopefully, if you have not subscribed, subscribe to it. If not, stay tuned to my Twitter handle or LinkedIn. And whenever we launch this video series, I'll post, and then you can look at it and preferably get a more deeper understanding into data cloud. So with that, I think it is now time to take in some questions.